Okay, class. Now starting with the revision of EMI. So magnetics we had completed. So EMI, AC, EM waves, let's try to complete with this. So firstly, let us see the important topics and points of EMI. Now see from EMI, the first important topic that can come is magnetic flux. So magnetic flux was what? Magnetic flux is written as B dot A, or we write it as BA cos theta. Number of field lines crossing area normally. And here theta is the angle between the unit vector that is perpendicular to the plane and the magnetic field. This is the angle that we take, not with the plane, with the area vector. Fine. So one more thing from here, you just formula based questions are asked. Just remember one thing, then 1 Tesla meter square is also known as 1 Weber. 1 Weber, that is the SI unit. This is important to remember because this can become confusing whether it was Tesla meter square or Weber is the SI unit of what. And remember the CGS unit, because CGS unit is also used, Maxwell. Maxwell can be written to you in the exam, or MX will be written to you in the exam. And remember the conversion, 1 Weber is equal to 10 to the power 8 Maxwell. Fine. Then Faraday conducted his experiments, all the 3 experiments. You should just read it once. Explanation, I have not seen it coming. Though just remember the laws of Faraday. Faraday's laws of EMI. Laws of EMI are very important, more than Faraday's experiments. So have a glance through the Faraday's experiment. Otherwise, laws of EMI are important. So 2 laws of EMI we have. First important law was that whenever magnetic flux linked with a closed circuit changes, EMF is induced in it. Introduction of EMF was given by the first law. And then magnitude was given by the second law. It said that it is equal to rate of change of magnetic flux, d phi over dt. But we had seen that we put a negative sign, minus d phi over dt. So this negative sign had the significance from Lenz law. Lenz law, we commonly call this law as Lenz law. Lenz law is also important. Theoretical questions come a lot from Lenz law. If direction is made this, I hope you all have given so many exams on EMI. Here also you have given, in your schools also you have given. So you must have noticed that the theoretical questions do come a lot, like a ring is kept, what is the direction, what should be direction of induced current, such questions. So what is Lenz law? Lenz law basically states that direction of the induced current. You all have the written notes, that's why I'm not making you write. So direction of induced current in a circuit is such that it opposes the cause that produces it. And what is the cause that can produce it? The cause is the change in magnetic flux. This is the cause. Right, class? This is the cause that produces it. So let's practice some questions on magnetic flux. No need to write these points which I have written. All of you have these. Let us practice numericals now. No, Khalid, wrong answer. See, a coil with an average diameter of 0.02 meter is placed perpendicularly to a magnetic field of 6,000 Tesla. If the induced EMF is 11 volt, when the magnetic field is changed to 1000 Tesla, in 4 seconds, you have to find out number of turns. See, radius of the coil is, diameter is given. So radius will be 0.02 divided by 2. That will be 0.01 meter. That will be the radius. Diameter divided by 2, 0.01 meters. Now see, initial magnetic field is 6,000. Initial magnetic field is 6,000 Tesla. And final magnetic field is 1,000 Tesla. All right. So change time is given as 4 seconds and EMF is given as 11 volt. So EMF is n times rate of change of flux. Yes, now the answer is correct. So d phi over dt. So this will be number of turns we have to find out. Leave the number of turns as it is. Number of turns. Flux is change in magnetic field into area. So B2 minus B1, area is pi r square divided by time period. So from here you will write the value of n. N will be ET divided by B2 minus B1 into pi r square. So n will be, EMF is 11, time is 4 seconds, right? So 11 into 4, then we have B2 minus B1. So 6,000 minus 1,000 multiplied by 3.14 into r square. So radius is 0.01. So this whole square. So when you solve this, you'll get answer as 28, as Khalid has correctly answered it. Note down the solution, then we'll move forward. Yes, Khalid, both the parts are correct. So only Khalid has answered. See, this is related to your motional EMF. So E is equal to BLV is the formula for motional EMF. But see, class, if you have a rod, no, then the formula of EMF or potential difference, basically this becomes half BR square omega. This becomes the formula for it. So directly use this formula, straight away put in the values and you'll get a proper answer. Magnetic field here it is given, yes, 0.2. R square radius is 0.1, no? Yes, 0.1 whole square. And omega is 20 pi. 20 into pi. When you solve this, you'll get it as 0.0628 volts. And see, class, for the second part, what is the induced current? Voltage you have from the first part. Resistance is given. Current can directly be answered by E by R. 0.0628 divided by 2, 0.0314. Write this much of amperes. Quickly note it down. Yes, Atif, correct answer. C class, when north pole of the magnet is moved towards the loop. See, when the north is moved towards the loop. Right, Khalid, correct. C, when the the north pole of the magnet is moved towards the loop, current is induced in which direction? North is approaching. To repel it, it will also develop north polarity. Yes, Salman, correct. It will also develop north polarity, and that will be anti-clockwise. This will be anti-clockwise, means direction of induced current. Direction of induced current will be anti-clockwise. So if this is the direction of current, means the charges are releasing from the positive end and they are entering the negative. It means this plate has positive polarity, this has negative, then only the charges are able to move in this direction. So it means A has positive polarity, B has negative. Note it down. Some more numericals let's do from this lesson, then we'll move on to questions from AC. Correct answer, Atif. Good. See, EMF is given to you. EMF is 0.5 volt, right? And what do we have is an EMF of 0.5 volt is developed in the secondary coil when the current in the primary coil changes from, okay, so there's a change in the current. DI is given 5 amperes to 2, means 2 minus 5, final minus initial, so that becomes minus 3 amperes. All right. And change in time will be taken as 3 milliseconds. dt will be 300 milliseconds. Convert milliseconds. So EMF, mutual inductance, EMF is minus mdi over dt. Not a difficult question. M will become E 0.5 into T is 300 into 10 to the power minus 3 by I is minus 3. This minus sign again. Right. So 100, 0.05 Henry. Easy. 0.08 nahi, 0.05 Khalid. Note it down. Then let's start with the questions from AC. See, a 200 millihenry means a pure inductor and a 5 microfarad pure capacitor. Both these are connected one by one across the sinusoidal AC voltage source. So voltage source is 70.7 sine 1000. Khalid has answered current for inductor. Okay, right. And for capacitor, correct. Sahi hai, Khalid. Very good, Khalid. Others also respond. I think Memuna, Sara, you both also try. You haven't answered once. So 70.7 sine 1000 T. Right. You have to obtain the expressions for the current in each case. So, yes, class. Each case means for inductor and capacitor. So let's start with inductor only. See, peak value of current is what? From this equation, this is V naught. Peak value 70.7 volt. Right. And omega is given. Yes, this is omega. Omega is 1000. Sahi hai, Salman. Correct answer, Salman. So for inductor, this will be V naught by XL. And XL is omega L. L we already have. This is L. So this will be 70.7 divided by omega into L. L is 200 millihenry. So that will be what you people are getting 0.355. Now, when you have to write down the expression, writing down the expression is not difficult. See, for inductor, we know current is lagging. So what we'll do, 0.355, that will be the peak value, omega t minus pi by 2. This will be the equation. Same thing when you have to find it. Same thing when you have to find it for capacitor. For inductor, you write Atif. For capacitor, also find it out. So I naught for capacitor will be same thing, but XC will be here and XC is 1 by omega C. So omega C will go up, V naught. Omega is there. It was 5, no? 5 microfarad. So 5 microfarad and potential was 70.7. So when you solve this, the same thing you will get. Yes, Salman. Right. Second part is also correct. Again, you will get the same thing, 0.355. But here we know current is leading. So now when you write the same equation, 0.355, you will write omega t plus pi by 2. That is just the difference. Very easy question, class. Just break it into parts and try to solve. Many of you have answered it. That's very good. Let's practice some more questions. Note it down first. And if you have any doubt also in any of the topics from this lesson, AC, EMI, let me know. Let's discuss this now. I think 2 to 3 minutes I've given, 5 minutes. 60-10 watt electric lamp is to be run on 100 volt, 60 hertz mean. You have to calculate the inductance of the choke required, and if the resistor to be used. Second part we'll see. First part, see EMF that is given to you. See E effective which you have, is 60 volt, right? And power is 10 watt. Okay. Now resistance is E effective square divided by power. I hope you remember P is equal to V square by R. P is equal to V square by R. So from this equation, you must be knowing that this can be exchanged and we can get this. So resistance, we can at least get it from here. 60 into 60 by 10, 360 ohm. And current through the lamp will be, it will actually be I effective. So P divided by E effective. 10 is the power, E effective is 60. So that will be 1 by 6 ampere. Leave it as 1 by 6 only. We'll see in the calculation. So first part is asking you inductance of the choke coil, L. So L can be answered if we have XL, and XL can be only answered if we have Z. So Z is E effective divided Z. Z is equal to E effective. See, this will actually be E prime. Let's write it as E prime. This is this effective. This is given, no, for the inductor. This was for the lamp, 60 volt. This is specifically for the inductor. Mains, no, on mains. This is the main power supply. So 100 volts. So let me write it as E prime. So E effective prime by I effective. So that will be 100 by 1 by 6. So 600. Z you already have, and you only have inductance connected, right? So Z, your proper in XL will be under root Z square minus R square. Z is always equal to XL R square minus XL square. We have this XL as XL square minus R square under root. So if we have to find out, it will be Z square minus R square. So from here, you can get the value of XL. So 600 whole square minus R kitna hai? 360. 360 whole square under root. When you'll solve this, you should get it around 480 ohms. Now you have XL, and XL is equal to 2 pi nu L. So this is unknown, everything is given. XL will be XL by 2 pi nu. This is an important question from your previous year only, but not very recent, not from your very recent papers, but it has appeared in your exam. So L will be 480 by 2, pi is 3.14. Frequency was how much? 60 hertz. No, 60 hertz. Yes, 100 volt and 60 hertz. So should be 2, then 16. Let me check the answer for this. Answer is 1.273 Henry. Fine. Now the value, second part is asking if a resistor is to be used in place of choke coil to achieve the same result. It means, what is the difference? It's like for the second part, this much has been given to you. This has been added. How much is required? How much was required? This extra portion that is coming was required. So here also the value of resistance, it will be what? 600 minus 360, which is equal to 240. T ohms, right? That will be the answer of it. Note it down, class. Question, did you write it? Yes, I think question you all have written. No? See, a 2 microfarad capacitor, 100 ohm resistor, and 8 Henry inductor are connected in series with an AC source. What should be the frequency of the source such that the current in the circuit is maximum? And what is this frequency called? So can any of you tell me what is this frequency called? When current in the circuit is maximum?
Resonant frequency.
Resonant frequency, correct.
Resonant frequency.
Yes, resonant frequency, natural frequency or resonant frequency. And if this frequency is and the formula of resonant frequency is 1 by 2 pi under root LC. So 1 by 2 pi into 1 by under root L inductor. Inductance is 8 and how much is it? 2 microfarad. So 2 into 10 to the power minus 6. So 16 under root 16, 4. So that becomes 1 by, let me write it as pi only. 1 by 6 under root 16 will become 4 into 10 to the power minus 3. So 1000 is there, 1000 will be above 1000 by 8 pi. This will be 1000 by 8 pi or 125 pi hertz. This will be the answer. Quickly note it down and text me done once completed, then I'll stop with the class. Quickly note it down, class. And do text me done in the chat box. Okay, fine, class. All those who have completed, you all can leave. We'll meet in the next class and then we'll do the revision of optics. Some important questions of optics from your previous years. Okay, do revise and come. Okay, thank you so much, class.
Thank you, ma'am.